Hello, my name is James Hilton, and today I will be displaying angular momentum with a homemade bicycle gyroscope. So let's discuss the materials that we will need for this project. So we will need a bicycle, 2 screw-on file handles, and a turntable or a laser Susan. So now we can start building our gyroscope. So what exactly is a gyroscope, and why am I using a bicycle wheel to demonstrate angular momentum? Well, a gyroscope is a device with a spinning disc or a wheel mechanism that harnesses the principle of conservation of angular momentum, which is the tendency for the spin of a system to remain constant unless subjected to external forces such as torque or friction. And like gyroscopes, the faster the angular velocity, the easier it is for it to stand upright and harder to upset momentum. So now that our bicycle wheel is removed, all we need to do now is screw on the file handles, and our gyroscope is going to be finished. The handles will be used for better grip when conducting our 3 experiments. So let's now demonstrate the mechanics of our newly made gyroscope. As you can see, angular velocity and momentum go clockwise, and angular acceleration is going counterclockwise. And all 3 vectors point perpendicular to the plane. In our first demonstration, we will be using the concept of gyroscopic motion to convey the conservation of angular momentum. Gyroscopic motion is the tendency of a rotating object to maintain the orientation of its rotation. The bike wheel possesses angular momentum, and the momentum must be conserved. The wheel will resist any change in its axis of rotation, as the change in the orientation will result in a change in angular momentum. This gyroscope in concept will keep spinning forever if there are no external forces. For demonstration number 2, I'm going to be conducting a balance test. I'm going to attempt to balance the gyroscope on one finger and using the other fingers as support. Now I'm going to try a couple times, but as you can see, it's pretty much impossible to balance it with one finger. However, if you spin it, you can tell that the angular velocity, which will increase the angular momentum, will allow the gyroscope bicycle wheel to stay on one finger and balance it. This is because angular momentum is forcing out perpendicular to the plane, and as the torque is pushing it in the opposite direction. So I spun it clockwise, but the torque is pushing it counterclockwise. And now I'm going to show the inverse of the previous effect. I'm going to spin it clockwise, but then I'm going to reach on the other side and grab it, so the wheel is spinning counterclockwise in reference to me, and which will allow the torque to turn it in the opposite direction. So the wheel is spinning counterclockwise, but the torque is wanting to push it clockwise. For our final demonstration number 3, I'm going to show conservation of angular momentum with a turntable and the gyroscope. So as you can see, as I tilt the wheel to the left, I go into a clockwise direction. Now if I spin it and I tilt the wheel to the right, I turn in a counterclockwise direction. Now why does this happen? Now, when I tilt the wheel in a certain direction, it tilts the angular momentum. And with conservation of angular momentum, my body needs to turn in order to keep it conserved. Thank you for watching, and I hope you enjoyed it.